And with this problem, the following formula gives the surface area S of a right cylinder, where R is the radius of the base and H is the height. So you can imagine that we have a cylinder, something that essentially looks like a soda can, and this is a right cylinder, meaning that the base and the height of this are perpendicular to each other. We know the height is h, the radius of the top or the bottom face, we can call that r. And let me rewrite that. So the radius of this is r, and s is the surface area. So if we measure how much space the outside of the cylinder actually takes up, then that will give us our surface area. And the formula for that is right here. S is 2 pi r multiplied by r plus h. And we need to rearrange the formula to highlight the height, which is the letter h. So let's start by just rewriting this formula. S is 2 times pi the radius multiplied by r plus h. And to solve this for h, we need to isolate this variable. And there are two approaches that we can take to this. We could distribute here to get rid of the parentheses and then subtract the term that doesn't have h, move that to the other side, and then divide to get h by itself. Or we can use division right away. And let's use the second approach. Since if we get rid of this multiplication right away, we can use division to do that. Then on the right-hand side, we will just be left with r plus h, and we can just subtract r. So let's divide to cancel out this factor on the outside, which is 2 pi r. So we can divide by 2 pi r on both sides of the equation. And that way on the right-hand side, these will cancel with each other so that we get s over 2 pi r is equal to this set of parentheses here, which at this point we could just drop the parentheses since we are just multiplying by 1, and 1 times anything is itself. And this just comes down to the fact that 2 pi r divided by 2 pi r, something divided by itself, is always equal to 1. So we have s over 2 pi r is equal to r plus h, and we need to isolate this for the variable h. So at this point, we just have this plus r attached to the h, and to cancel out addition, we will use subtraction. So we get that s over 2 pi r minus r is equal to h. And this here is what we would put in the box up here. Though, like I did mention, if we wanted, we could also solve this with a different approach. And that approach would be using distribution. So we can distribute the 2 pi r to each of these. We would get that s is 2 pi r multiplied by r, which would make this r squared. And we would have 2 pi r multiplied by h. And now we can subtract off the term that doesn't have h in it. So let's subtract 2 pi r squared from each side. So we get s minus 2 pi r squared is 2 pi r multiplied by h. And now to get h by itself, let's divide both sides by 2 pi r. And when using division, we need to be sure to divide everything by 2 pi r. So this just becomes s over 2 pi r. But this here, notice we have 2 pi over 2 pi, so those cancel. And we have r squared divided by r, which will cancel out one of the r's up top with the r in the denominator, meaning that we would just be left with r. And that is exactly what we found when we solved it with a slightly different method. So with many of these problems, there are different approaches that can be taken. And sometimes it's useful to use multiple approaches to make sure that you end up with the same answer for each approach, and that's one way to feel a little bit more confident that you're doing this correctly.